Absolute value inequalities. Okay. So this was on our notes yesterday. We said the absolute value of x is the distance from x to 0. That's not new. That's literally what absolute value means. Absolute value of x is the distance from x to 0. Let me see if I can zoom in. Oh. Come on, document camera, don't fail me now. Go. Zoom. Huh. Okay. I think that's as much as it's going to zoom. Can we read that kind of ish? Okay. All right. Now, if I say the absolute value of x equals 3, then what I am saying is the distance from x to 0 is 3. And I'm saying it's exactly 3. It is a distance of 3 from 0. So that means it's positive 3 and it's negative 3. It's two answers, right? The distance of 3 from 0. It's positive 3, it's negative 3. We can draw a little number line for this. This could be helpful. So here's 0, and we got 1, 2, 3. 3. 1, 2, 3. Negative 3. Two specific answers, that's it. Okay, now we're going to look at the inequalities, because this is when things start to get a little bit weird. If I say the absolute value of x is less than 5, I am saying the distance from x to 0 is less than 5. So now I have a lot of answers because there's a lot of numbers that have a distance to 0 that's less than 5, right? Like 1 has a distance to 0 that's less than 5. 1.2, 3, square root of 4, square root of 5. All those numbers, all those decimals, all of those have a distance to 0 that is less than 5, right? Yeah, Court. Does now seem like a good time to leave and get water? Yeah, probably not. Okay. Okay, so I'm counting to 5 and negative 5. So I can't go to 5 exactly because my distance has to be less than that. So I can't go there exactly. I'm not going to fill this in. But all of the numbers from 0 up to 5 are going to work. All of these numbers have a distance that is less than 5. So all those ones work as long as I don't get all the way to 5. That's why I shaded in. But I didn't shade in 5 because that's a distance of exactly 5. And I did not have an equal to sign there. So I didn't shade it in. Same thing over here at negative 5. I'm not going to shade in the negative 5 because that would be a distance of exactly 5. And my inequality doesn't say exactly 5. It says less than 5. So I'm going to shade in all these distances as well. So all those numbers are solutions as well. So when we solve equations, we have specific solutions, 2 of them. A positive version and negative version of the equation gives us 2 solutions. With inequalities, just like the other day when we did inequalities, we found infinitely many solutions because we had all our decimal answers. Again, today we have infinitely many solutions. Okay? Now, I always write my answers like this. So we've got x is in between negative 5 and 5. And This symbol right here, when you say it out loud, you say less than, right? That's how we say it. We say less than. I write this whenever I do these. These are called compound inequalities when you're solving an absolute value inequality like this. I say it as less than. I want you to write this in your notes. Less than. It's in between -5 and 5. That's going to be important. It's going to be like a shortcut for how you write your answer, okay? It's a less than sign. The answer makes a sandwich. It's in between one answer and another answer. That's important, okay? Less than. I don't know, if you got colors over there, maybe put a color on there. Less than. That's important. This symbol is important, okay? All right, let's do the next one. We got absolute value of x is greater than or equal to 4. And this means the distance, I wrote the with an A. No, nobody? Okay. The distance from x to 0 is greater than or equal to 4. Okay, so let's draw our number line. 0, 1, 2, 3, 4, 1, 2, 3, 4. The distance is greater than or equal to 4. So can the distance be 4 exactly? Yes. Okay, so it can equal, the number can equal -4, the number can equal +4. Should I be shading in between the numbers? No, the distance has to be more than 4. It has to be more than 4. So the shading has to go opposite directions. It has to be the numbers that are a distance greater than 4 away from 0. Okay? Now, when we say this symbol, how do we say it out loud? Greater, okay? So when I write this, I'm going to say x is less than or equal to -4, or x is greater than or equal to 4. Now, this symbol we call great or. You guys get it? Great or, less than. It's between one number and another number. Greater, it's one answer or another answer. Greater, less than. Get it? Those are my little tricks for you today. Now, the hard part about this lesson is that if you mix up the symbols, the answers, the numeric answers are going to be the same, even if you solve it wrong with the symbols. So if I had this symbol wrong and I did the or version of the answer, my numbers still would have been -5 and 5, but my answer would have been completely wrong. And I could have used the wrong symbol and done the sandwich version, and my numbers still would have been -4 and 4, but my answer would have been completely wrong. Okay? So it's really important that when you get to this point, you're paying attention to which way the symbol goes, because when it comes down to it, it's probably not the numbers you're going to get wrong, it's probably the symbol. Okay? So less than, greater. That's how it goes. And is a sandwich, or is opposite directions. Okay? And this is what we're always going to come back to, so we're going to have our notes out in front of us so we can remember this picture. Less than to greater. Okay? Now, the point where you decide which way they go is not the beginning of the problem. Don't tell me at the beginning of the problem which answer you have. The time you decide which answer you have is when you get to the point where the absolute value is alone on one side and a number is alone on the other side. Because when you do it, your symbol flips. So in the problem, you could divide by a negative symbol, and that's your predicting of the problem. Okay? We're not going to at the very beginning, because you know my favorite to do is put some negative symbols and mine in the middle. Okay. You know I'm going to do that, right? You know I'm going to do that? Okay. All right. Some problems with whole numbers now. Come on, screen. All right, let's go. Example 1. We're sighing already. It's a good sign. It's a good sign. Okay, I'm going to stop. All right, -4, absolute value, 3n plus 6, less than or equal to -24, no commitment yet. We're still going to do order of operations backwards. So is there anything I can add or subtract over to the other side? Add or subtract? Nah, nothing to add or subtract. Is there anything I can multiply or divide over to the other side? Yes. What is it? -4. I'm going to divide by a -4. What happens when I divide by a negative? You get the positive. What else happens? You flip your symbol. Okay? How do I say this symbol out loud? Greater. Okay? We are going to have one or the other. Greater. Okay? So everybody write greater. Greater. Okay? So this is where we have our two versions. The first version is 3n plus 6 is less than or equal to -6. Okay, so we're going to have one version going towards the left, and then we got one version going towards the right. 3n plus 6 is greater than or equal to +6. So see that? Left version, right version. We got the versions going opposite directions. Everyone see that? Greater. Left or, well, I'll go this way. Left or right. Greater. Opposite directions. Does that make sense? Okay. Now we just solve. Solve like normal. Okay. So what should I do here? Subtract the 6. -6 minus 6. Awkward. Negative. I don't know why I wrote a -3. There we go. -6 minus 6 is -12. -12 divided by 3. -4. So n is less than or equal to -4. Okay, so there's one part of our answer. Okay. We didn't divide by a negative, we subtracted a number, which isn't dividing. Good question. All right, what do we do over here? Subtract the 6. All right, we get 3n. 6 minus 6 is 0. Okay, and then what do I do? Divided by 3. 0 divided by 3, 0. So we get n is greater than or equal to 0. And so your options are n is less than or equal to 4, or it's greater than or equal to 0. They're going two opposite directions. Less than or equal to 4, or greater than or equal to 0. Yeah.
So for the negative, can we put it on the side that is with the n? Can we put the negative on that side?
Oh, put the negative over here?
Yeah, it got the same answer.
And then put a +6 right here?
Yeah.
Yeah, you can do that.
Okay.
Yep. Okay. Here is our next example problem. Example 2. We have absolute value of 6 plus 7x plus 2 is less than 52. All right. PEMDAS backwards. First step. Okay, so we are looking for something we could add or subtract over. We can subtract the 2 over. It's less than 50. Okay. We are at this point, we have the absolute value is alone on one side and the numbers alone on the other. So now at this point, we can look at the symbol and say what the symbol sounds like when you read it out loud. So when you read the symbol out loud, what is the symbol? Less than. Less than. Okay, so when we read this, when we do this one, this is not one direction or the other direction. This is less than. This is making a sandwich. Okay? It's between one number and the other number. The two numbers that we're sandwiching this one between is negative 50 and positive 50. That's what we're sandwiching it between. Okay? The thing that goes in the middle of the sandwich is the 6 plus 7x. Okay? So I'm going to say negative 50 is less than 6 plus 7x, which is less than positive 50. I'm making a sandwich. Less than. All right? So if you're trying to get the x alone, what's the first thing you could do? Minus the 6. And when we do that, we want to, like if you were thinking of it like an equation, you would normally do something to the left side and do it to the right side. So here we think of doing it to like all three sides. Do it to the middle, do it to the left, do it to the right. So we do, whatever we do, we keep it balanced. So we got rid of the 6 in the middle. Negative 50 minus 6 is negative 56. 50 minus 6 is 44. Okay. And then how do we get the x alone in the middle? Divide by 7. Now, it's pretty common for these to have a fraction somewhere in the final answer. So if you get some fractions for these, don't stress. Okay. 44 sevenths does not reduce, so we're going to leave that as 44 sevenths, even though it feels a little cringy. 56 over 7, negative 8. And we're done. So it was a less than problem, and we ended up with a sandwich. It's between one number and another number. How do your brains feel? It's fourth period. All right, which type of problem do you feel less comfortable with? Less than or greater? Or should I surprise you? So mostly just do another example. We should just do another one. Yeah, okay, let's do it. 5 minus 7 times the absolute value of negative 9x plus 10 is greater than negative 51. You know it's a good sign when I got all those negatives in one problem. You know it's going to be good. You guys are like, negatives, no. That means it's going to be flipping back and forth. Yes. It's just a 5. 5 minus 7, absolute value negative 9x plus 10, absolute value, greater than negative 51. All right. Is there something we could add or subtract to the other side? Yes. Uh-huh. To the negative 51, you mean?
Oh, I thought that was another bracket thing.
Yeah, it's a 51. Okay, so what should we do with the 5? Subtract it. Okay. So now it's negative 56. Okay. Now what should we do? Divide the negative 7. So the next step is to multiply or divide something to the other side. We're going to divide the negative 7. And we got to flip the sign. Okay. And we are at the point where the absolute value sign is by itself. And we got a number, and the number's positive. So that's good, because if the number was negative, what would our conclusion be? No solution. Okay. Port, yes. We flip the sign because anytime you're doing an inequality and you divide by negative, you have to flip the symbol. Okay. So absolute values alone, we got the number. This is the point where we read the symbol and see what it says. So what is this symbol? Less than. What does less than tell us? Sandwich. Okay, what are the numbers that we are sandwiching in between? Perfect. Very good. Okay. All right, now what should I do? Subtract the 10. So we've got negative 18 is less than negative 9x is less than negative 2. And now what should we do? Okay, and we're dividing by a negative, so what's going to happen? We got to flip all of our symbols. So we got 2, flip, x, flip, 2/9. Now, most people would not leave something like this with the smallest number on the right and the biggest number on the left, because we're Americans. We read from left to right in this here country. So we're going to put the 2/9 on the left. We're going to put the 2 on the right. We're going to put the x in the middle. And I can see that with the 2/9, the little part points to the 2/9. Can you see that? So I'm going to make the little part point to the 2/9. It does. We're going to be proper here. Have you met any math people that are just like laid back about math? No, I'm not going to take points off, but if you went to like a college math class and tried to do that, they'd look at you like you were an idiot. I know, but you're also not in year-long math 3. You like chose to take honors. So, yes. You should feel complimented. I'm holding you to a higher standard because you took the Smarty McFarty math. So, Smarty McFarty is the technical term. All right. These are your notes. Keep them out. The most important part of your notes, I think, is this part maybe. Less than, greater, maybe. I don't know. Yes. Mm-hmm. Every single time you divide by a negative, flip. Divide by negative, flip. You can add a negative, subtract a negative, and those don't flip. But if you divide by a negative, you're gonna flip it. Ooh, we got 15 minutes. We got some math to do, man. So I'm gonna make you hold it for 15 minutes.